I'd like to begin with a question. Who here knows of something called PyData? 1, 2, 3, 4, 5, 6. All right, not too many people. There's a few conferences in the Python ecosystem. PyCon is the one that's known by most people, but then there's DjangoCon, and then there's another kind of subset of scientific computing. One of those is ChiPy, and then more recently, PyData. And so there was a recent PyData conference in New York last week, which I attended. And so they're doing a lot of cool things, so I'd like to speak about that. But first off, I'd like to just give a kind of general comment about attending conferences. Who here has attended a conference? Almost everybody. I'm seeing a few no hands. Attending conferences for Python is really, really cool. 1, you get to learn a lot of stuff. 2, there's often tutorials. And then 3, you get to meet other Python developers. And so if you ever get the chance, I think you should host a fellow traveler coming in. I was actually hosted at this event by a guy. He didn't attend the conference, but he hosted me and he hosted another Python guy. And it worked out in the most awesome fashion. The other guy happened to be from Baltimore. So he drives up and he picks me up at LaGuardia. And then we drive over to this other guy's house, and the fellow traveler is carrying a cooler filled with Maryland crabs. And so we all sat there eating these just awesome Maryland crabs for the night, drinking beer, chatting about stuff. And through that small instance, like a bond was formed. And you get to develop yourself in the community. You get to grow. You get to meet new people. And those relationships hold. You know, if I'm ever in the area, I have somebody to call. If somebody else is coming to the Chicagoland area, they have somebody to call. And that's really, really important, because when I attend the conferences, I attend not necessarily for the talks, because I think we all know if you go to YouTube, if you go to Vimeo, those things are online. We attend for the people. So if you ever get the chance, get involved within the community and host. Now, about PyData. There were a few talks that I really, really liked. One was given by Travis Oliphant on something called Conda. Who here uses virtual env? Almost everybody. So Conda is like that, but it's better. Now, one of the problems that the scientific computing community deals with is that we have C code, we have Fortran code, we have all these like compiled libraries. And Conda takes that and allows you to create environments based off of compiled code that just works. You can package it all up together and you can ship it off. And so it's an open source package. You can get it through Conda, which is, you can get it through Anaconda, which is Continuum's Python distribution. So I encourage everybody to check it out. There was a little interesting moment, which was kind of funny. There was a panel, about 4 people were kind of talking, and somebody asked a question. Said, well, I have a certain problem. How do I do this? And Travis would reply, oh, well, Conda is really just the answer to that. So I encourage everybody, to try it out. You can clone things. You can ship things. You can bundle things together. You can create any kind of recipes with various dependencies. You can switch back and forth, right? You can say, hey, I want to try something out with Python 3. I want to try something out with 2.7 or 2.6. You can specify that. And so I think that's really, really cool. One of the other talks was given by a guy, and I'm kind of bastardized his name, but he's German. His name was Yves. And he gave a talk about high-performance computing in Python. And that was really, really cool, because who here has seen Python sped up 1,500 times? Yeah. All right, we got one person. All right. So it's really cool to see Python used in these kinds of areas, because one of the complaints about it is that it's slow. But a lot of the stuff calls C underneath. There's a lot of tricks that you can use to speed up functions. NumPy is one, and it's just kind of built in. But there's other really, really cool things. So one of the things that Continuum is developing is something called Numba. And Numba is a kind of Python compiler. And this is really, really cool, because it takes your Python code And it breaks it down in something called LLVM, a low-level virtual machine. And there's an IR, which is an intermediate representation. But you compile it down to this LLVM, and this LLVM works on any kind of hardware. So it's just this little interface for the hardware between it. So somebody was talking here earlier about open hardware. This might be one way to get Python on anything that you want. And it's cool because it compiles down to the bytecode. And so it runs really, really, really fast. And so they can take things with Numba and they can compile it. And then they can compile it for any kind of hardware. They can compile it for GPU. And so this is part of the way that Python can be involved in any kind of computing going forward. Now, Peter Wang, who's another Continuum guy, I have to maybe kind of preface, Continuum was a large sponsor of the conference, so they had a lot of speakers. But you know, he gave an excellent talk on the kind of future of scientific computing. And one of the things that's nice about Python is that it allows developers to get really, really close to their domain. The problem is that you have certain problems and the languages aren't close to the data, or they're not close to the problem. And so it's very difficult to solve certain types of complex problems when the languages and the data are very, very far away. And so his talk was a little bit philosophical, but I think that he points to a future where it doesn't really matter what kind of hardware we're working on. It doesn't really matter what kind of database that we're working on. Because through technologies like LLVM, it'll all just compile to that, and it'll run to that. One of the last talks that I saw, which was really cool, was given by Wes McKinney, who's the author of Pandas. And he gave a talk, he changed the title at the last moment, but it was 10 things that I hate about Pandas. And I'm a huge user of Pandas. It's one of the best things that happened to Python in a long time. And it's really cool to see an author of a library talk about things that he doesn't like. Because most often we see things that it's like, yeah, this is really, really cool. And you go to these conferences and you meet other people in the community and they're like, yeah, this library solves all of my problems. And then here's the author's like, yeah, the database integration kind of sucks. It all works with like in-memory things. So if you have a really, really large data set, there's no memory mapping going on. Or it's really slow. We don't do any kind of streaming. And so this is kind of fun. It's fun to see that. But from that conference, from that specific talk, I learned something else. Wes has a company that's called DataPad, and they're building this kind of business intelligence analytics platform. And he's created something that he called Badger. And Badger right now is closed in the sense that he doesn't have the time nor necessarily the resources to take on an open source project. And so that really made me think a lot about what it means to be an open source project, what it means to like develop software for production, for performance. So in conclusion, I think Python really has a lot to offer. It has a lot to offer for just web development communities. It has a lot to offer for scientific and numerical computing communities. And so I encourage everybody, if they're interested in this kind of thing, to attend a conference. They can check out the PyVideo talks. It's hosted on vimeo.com/PyData. Thank you.